Welcome to solverfy.
Hello there. So now we are going to work with passwords for a computer. So there are some restrictions for this password, and is that the length of this password should be at least 8, and the maximum of the length is going to be 12. And the password can contain the following characters. So it can contain the uppercase English letters, lowercase English letters, digits, and 6 special characters like the multiplication, the less than, greater than. The important thing is that there are 6 special characters. So how many possible passwords are possible? So the first thing that we need to calculate is how many possibilities for each element on the password we have. So we have 26 uppercase letters, 26 lowercase letters, we have 10 possible digits, and the 6 special characters. So this gives us a result of 68 possible characters for our password. Okay, so each position in the password is going to have 68 possibilities to have one of these characters that I am specifying here. So take into account that 68 possible characters, right? So we have each element on this password are going to have 8 characters. Now, to count how many possible passwords there are, let's consider an arbitrary k-length password. Okay, so if we have a k-length password, that means that we have k positions, right, in our password. Here we have k positions, and for each position on the password we have 68 possibilities to put one of the characters that I mentioned before, right? So at the end, for a k length password we have 68 to the kth power possible passwords. Okay, but now we have a limit for the length, and is that the length of the password k should be less than 12, less or equal, and greater or equal than 8. So this gives us a range of the length of the password, and k of course is going to be an integer value, positive integer value. So the possible passwords that we can have, it's going to be given by the sum from k equals to 8 to 12 of 68 to the power of k. And this will give us an approximate value. I'm not going to calculate this. This is around 9.9 times 10 to the 21 power in scientific notation. So these are all the possible passwords that we can have with these conditions. Great. And now we need to count how many of those passwords contains at least one occurrence of at least one special character. Let's remember that the number of special characters is equals to 6. Okay, so we have 6 special characters for this kind of passwords, and we need to count how many of these passwords contain at least one of these occurrences. So this is equals to take all the possibilities, all the possible passwords, minus all the passwords that do not contain the special characters. So let me put differently. Let me put like all the passwords that do not contain the special characters SC. Okay, we are negating this fact. So no occurrence of special characters, and that is a lot easier to calculate. So first, let's remember that we have already calculated this PP is just all the possible passwords that we can have, right? Given that those conditions, and this is 9.9 times 10 to the 21 possible ways. Okay, so these approximate. Now to count those that are so no special occurrence means that now we are not having the 68 possible characters for our password, but now we need to subtract the 6 special characters, and that means that we have 62 characters for our password that do not contain the special characters. We have, again, in this case, those that doesn't contain the special characters going to be the sum from k equals to 8 until 12 to count all the possibilities of this kind of passwords. But now instead of 68 we have 62 possible characters for each position in the password. So we have here 62 to the k power. And this number is around, the approximation of this number is 3.3 10 to the 21. And we need to calculate the subtraction of these two quantities. So all the possible passwords minus the passwords that do not contain the special characters, it's going to be 9.9 times 10 to the 21 minus 3.3 times 10 to the 21, and this is equals to 6.6 times 10 to the 21 power. Or if you want to write it, well, of course, I forgot to mention this is an approximation, right? This is not the actual value. If you want the full formal value to write this expression here is not that hard. It's just expressing as a summation from k equals to 8 until 12 of 68 to the k power minus 62 to the k power, and that's all. And finally, we need to, let's assume that there is a hacker that want to try all the possible passwords. Okay, and to check each password, it spends 1 to the 10 to the minus 9 seconds, okay, or in other words 1 nanosecond, okay, 1 nanosecond to check each password. So let's remember that all the possible passwords that we have is equals to 9.9 times 10 to the 21, and we're going to spend 1 nanosecond for each to check each password. So if we want to calculate the whole time, we just need to calculate, we need to multiply all the possibilities times the time spent to check each password, that is 10 to the minus 9, and this results into 9.9 times 10 to the 12 seconds. It is still a lot of time, but let me illustrate you that this is indeed a lot of time. So here we have seconds, so we can transform this to, we know that 3,600 seconds is equals to 1 hour, and 24 hours is equals to 1 day, and 365 days is equals to 1 year, right? So if we divide this by this quantity, we obtain that the time spent by the hacker to check all the possible password, if he spent 1 nanosecond for each password, is equals to 314,500 682 years.